Today we're going to talk about the most incredible survival story that's happening inside your body, like right now. It's this constant, high-stakes battle to protect its most precious asset, the brain.
4 minutes. That's it. That is the entire window of time you have before irreversible damage starts to happen when the blood supply to your brain gets cut off. I mean, just think about that. It's an unbelievably short amount of time.
So how does your body pull this off? How does it protect its command center? Well, it turns out your body has this absolutely ingenious, multi-layered defense system that is working around the clock to make sure that 4-minute timer never, ever starts.
Okay, so to really get the solution, we first have to understand the problem. And the problem, fundamentally, is that your brain is just incredibly needy. It has this massive, insatiable appetite. It's only about 2% of your body's weight, but it gobbles up a whopping 20% of your oxygen and glucose. That's way more than any other organ its size.
And because it's so fragile, there is literally zero margin for error. A constant, stable blood supply isn't just a nice-to-have. Nope, it is absolutely everything. The stakes just could not be any higher.
So how does the body handle this immense pressure? Well, it starts with the hardware, the physical structures that are basically hardwired into our anatomy for maximum protection and, really importantly, for redundancy. And the very first line of defense is this brilliant piece of biological engineering, a network of connections called anastomosis. The easiest way to think of them is as built-in detours or backup routes for your blood flow. It's like having a bunch of back roads already built into the system, just in case of a traffic jam. And this is the most famous example of that, the Circle of Willis. It's basically a traffic circle, a roundabout, right at the base of your brain that connects several major arteries. So if one road gets blocked, no big deal. Blood can just be rerouted through the circle to get exactly where it needs to go, preventing a total system failure. Pretty smart, right?
All right, let's move on to the next structural safeguard. This one is less about routing and more about, well, security. It's the blood-brain barrier. And this isn't just some simple wall. It's a highly selective 4-layer security system. We're talking specialized cells, membranes, even little projections from other brain cells, all working together in perfect harmony.
Its whole job is to be the brain's bouncer. I mean, seriously, think of it like the toughest bouncer at the most exclusive club in the world, meticulously checking the ID of every single molecule that tries to get in. It is all about controlling access.
And if you look at the guest list, you can really see it in action. It lets all the essential VIPs, like oxygen and carbon dioxide, pass right through. But it firmly denies entry to anything that could be trouble. We're talking certain ions, hormones, and neurotoxins that could totally wreck the brain's delicate chemical balance. Nope, not on the list.
Okay, so that's the hardware, the physical stuff. Now let's look at the software, the body's dynamic, functional systems that are actively responding to changing conditions in real time. This is where things get really clever.
This is something called autoregulation, and you can just think of it as a smart plumbing system. There are 2 main types. The first is myogenic, and it reacts to physical pressure. So if your blood pressure spikes, the vessels automatically constrict to protect the brain. Then you've got the metabolic response, which reacts to chemicals, specifically carbon dioxide. The more CO2 there is, the more active your brain is, so the vessels dilate to ramp up blood flow.
So what happens when these incredibly sophisticated systems get pushed to their absolute breaking point? Let's say by a head injury that causes dangerous swelling inside the skull. What happens then?
This is where the body initiates a kind of emergency override. It's called the Cushing reflex. When the pressure inside the skull gets so high that it starts crushing blood vessels, the brainstem sends out a desperate SOS. It tells the body to crank up blood pressure everywhere else to try and force blood into the brain. But then, and this is wild, other sensors in your body detect this insane pressure spike and they slam on the brakes by dramatically slowing the heart down. It's a full-on war inside your body.
So, and this is the crucial point, this internal battle for survival actually produces 3 classic external signs that doctors look for. You get dangerously high blood pressure, a really slow heart rate, and irregular breathing because of all that pressure on the brainstem. Together, this is known as Cushing's triad, and it is a sign of a dire neurological emergency.
Okay, let's dial it back from a critical emergency to something way more common, but something that uses the exact same systems we've been talking about, fainting, or what doctors call syncope.
If you have ever felt that dizzy, lightheaded sensation when you're panicking and breathing way too fast, well, guess what? You have actually felt metabolic autoregulation happening in real time. It's a perfect, real-world demonstration of this system.
So here's how it goes down. It all starts when you hyperventilate. You're breathing so fast and so deep that you start blowing off carbon dioxide much faster than your body can actually produce it.
And this leads to a state called hypercapnia, which is just a fancy way of saying the level of CO2 in your arterial blood drops, and drops fast. So what does the brain's smart flow system do when it detects low CO2? Well, just like we saw on that autoregulation chart, it triggers vasoconstriction. It tightens up the arteries leading to the brain. This constriction reduces blood flow just enough to momentarily starve the brain of the oxygen it's demanding. And the result? You get a temporary loss of consciousness. You faint.
But here is the absolutely brilliant part. Fainting isn't a system failure. It's actually a built-in safety protocol. It's a physiological reset switch. It forces you to stop hyperventilating. Once you're out, your breathing automatically normalizes. Your CO2 levels rise back up, the blood vessels dilate again, and you wake up. It's the body's dramatic, sure, but super effective way of fixing the problem you accidentally created.
So, when you look at the whole picture, from built-in traffic circles and microscopic bouncers, to smart plumbing that adjusts on the fly, and even last-ditch emergency overrides, the body's dedication to protecting the brain is just nothing short of extraordinary. Which leaves us with a final thought, right? If the body goes to these incredible lengths to protect this one organ, what does that tell us about all the others?